In this video, we are going to review some basic concepts about pointer. So this project has three files. util.h, util.cpp just contains a pause function so that the screen won't flash away. So it's just a very simple implementation here, reading a character so that the screen can pause for us. Now let's focus on this reviewPtr.cpp file. So in order to use that header file, we need to include the util.h, and this block of code is for memory leak checking, and this line to enable memory leak checking. Alright, so the first variable is a pointer to an integer, which means var is going to contain an address of an integer. Now let's take a look at var2. var2 is going to be a pointer to a pointer of integer. So we will look at it later. And we have an integer data type num. Also, we have a pointer to a student. So let's see, student is a struct we created here. So pointers, they do have type. You see, this is a pointer to integer, this is a pointer to an integer pointer, and this is a pointer to a student object. Now let's take a look at this operator, ampersand. So that's called the address of. You can take the address of any variable. So it just gave you back the address of that variable. And the num is an integer, so this will give you back an address of integer. Then you assign it to an integer pointer. Alright, and this operator, we call it a dereference operator. For dereference operator, you have to give it a pointer. This means I'm going to reference the memory var points to. So I'm trying to draw here. Please forgive me forgive my very rough skill of mouse drawing here. I'm going to try it. So if this is num, so this variable, if this is num, okay, this is num, not very good. Alright, and now this is var. It's getting better. Alright, so this assignment, we're trying to take the address of num and put it in var. So we establish something like this. This is a pointer diagram. So now var points to num. So about this memory, right now this num memory, we have two ways to access it. One way is through this num, that's a direct way. Another way is through this pointer. Like here, we dereference var and put 10 there. So when we dereference var, we are accessing this memory. Now let's keep on going. So var2, we take the address of var and put it in var2. So I'm going to draw var2 here. Alright, so we take the address of var. So pointers, they have address too. So, and we put it in var2. So this is the diagram. Then we say, alright, after we establish this diagram, let's see, I'm trying to dereference var2. So dereference var2 means I'm trying to access the memory var2 points to, which is this memory. And says I'm going to create a new int. So this link is broken. So it's pointing to an array of integer which has 3 int there. Okay, I'm allocating this memory. So this is another new operator. This is our third new operator we learn about, address of, dereference, and this is a new operator. When you use new operator, you are asking for memory allocation at runtime. So this this memory here around here, that's what you allocate at runtime. So then you have to remember later on when you're done with this memory, you have to delete it. It's your responsibility to delete this memory because the compiler has no idea you allocated at runtime. Alright, and now let's try to look at this. Let's say var bracket 0. So this is var bracket 0 equal to 1. So we're trying to access this element of the array, then var bracket 1 equal to 2. Alright, so I want to point out this bracket notation. Essentially what's going on is it first dereference var, then plus 0, it first var plus 0. Actually, it's first var plus 0, then dereference equal to 1. And okay, take a look at this is var. When you dereference var, that's the first element of the array. So now we know actually var just contains the address of the first element of the array. At this point, you should know like the array name. Any array name, static array or dynamic array, it's simply a pointer to the first element of the array. So the array name contains the starting address of the array. Alright, now when you try to access the second element, you first do a pointer arithmetic. So var plus 1 isn't just the integer arithmetic, it's a pointer arithmetic. So that means okay, now var plus 1 gave us the address of the second element of the array, and we dereference this address, we put 2 there. Alright, so then now let's continue. So student 1. So we have a pointer to student, and student 1, we are trying to access the GPA field. So you see student data type has a GPA field. We're trying to access this field, and this big arrow is equivalent to first dereference this student 1, because student 1 is a pointer. So we have to get to the real object first. You dereference the pointer, you get to the object, then you use this member access operator, this dot, to access the GPA field. Alright, now this big arrow is just a shorthand notation for this first dereference, then parentheses, then dot. Okay, and this line of code, if you go ahead and build, we should have no trouble building this. So the compiler shouldn't complain about anything. It has some warnings, but don't worry about it now. But when we run it, now let's see. Okay, we got the program crash. So what's going on here? So this time let's do start debugging here. And break. You see it doesn't like this line of code. So it break right here. So this is a line where the code crash. So let's take a look at what's going on here. You see var contains address, var2 contains address 2, and student 1. Take a look at student 1. Student 1 is a pointer, and it's a bad pointer now, because student 1 isn't pointing to anywhere. So you don't have a student object associated with student 1 yet. So this is the number one crashing reason. You're trying to access some memory that isn't allocated yet. So what we need to do now is we need to first allocate the memory for student object. So let's go ahead and stop debugging. So I'm going to allocate this memory. Alright, after we allocate this memory, let's see. again the program crash. So I'm going to break the code and take a look at what's going on here. So let's take a look at the call stack. The call stack, this is the main function, and this is where it's in trouble. String copy is in trouble. And let's take a look at why it's in trouble. I'm trying to copy G10 to student ID, and let's take a look at this ID. It's a pointer. Again, we haven't allocated memory for that ID yet, and we are trying to access the memory. So we have the same problem again. So what we need to do is first allocate memory for this ID. So I'm going to just give it a literal value here. And now let's take a look. This time it didn't crash, which is good news. But let's take a look at the report from the memory leak detection tool. And it says detected memory leak. So we have a bunch of memory leak here, like G10 and more than that, actually, not just G10. So you see, whenever you use new operator, that means you're asking for memory at runtime. Then it's your responsibility to release those memory after you're done with them. So we didn't release anything here, so that's why we're in trouble. So let's go ahead, release the memory first, release the dynamically allocated array, and that array should be var, not var2, because we dereference var2, so that array is var. And now let's delete the student1. Maybe it's a good idea to delete ID first. Imagine this. Okay, let's go ahead and use that draw tool again. So here's a picture. So this is student1. So this is student1. I really need to practice on this pointer drawing here. Student1. Okay, student1 is just a pointer point to a student object. And this student object contains an ID field. And this ID point to G10 now. So there's G10. And we have a GPA here. There's a GPA. Alright, so this is a picture. The dynamic memory we have here is G10. That's a 1. We allocated this ID field. We allocate at runtime. So this is dynamic memory. We need to get rid of this memory. And also this whole student object, that's what we allocated at runtime. So it's definitely a better idea to first delete this one. If we're trying to delete student object first, then we lose this pointer to ID. We will have trouble deleting G10. So we need to first do this. After we are done with this one, we can delete this. Alright, so we need to first delete So when we delete student1, actually we didn't delete the pointer. We delete the memory student1 point to, and student1 as a pointer, it's just a local variable here in main function. After main exit, that memory will be released. It will be wiped off the stack. Alright, let's go ahead and build. And start debugging. And this time, the memory leak detection tool didn't say anything, so no news is good news. We don't have memory leak. So this video shows you the usage of ampersand. This is an address of operator, dereference operator, you can use address of operator on any variable. And dereference operator has to be associated with a pointer because you're trying to reference the memory the pointer points to. Also, we review what's in array name. Array name just contains the address of the first element of the array. And also we review about allocating memory before you're trying to access them and release the memory you allocated at the runtime. Thank you.